Now, in this lecture, we will find out the value of angle ADC using two different methods. In the drawing, we have triangle ABC. We know that angle ABC equals to 30 degrees, angle ACD equals to 100 degrees. We also know that side AD equals to side BC, and we want to find out the value of this angle, angle ADC. So we start with the first method, and we will define side AC of triangle ABC as A, that is to say the length of side AC is equal to A units, and we will also define side BC of triangle ABC as B, that is to say the length of side BC is equal to B units. And it is given us in the question that AD equals to BC, but according to our definition, BC equals to B units. So from this equation, AD equals to BC equals to B, we will derive that AD also equals to B. AD equals to B. So we can write here that AD equals to B. In the next step, I will present to you a new law that is actually the law of sines. The law of sines is true in any triangle. So I'll write down that in any triangle, if we have triangle ABC, that could be any triangle, this is triangle ABC, and we know that side BC of triangle ABC equals to A units in its length, and this angle is angle A. Side AB, side AC, this side of triangle ABC equals to B units in its length, and this is angle B. And we also know that side AB of this triangle ABC equals to 3 units in its length, and this is angle C. Then, according to the law of sines, A over sine A equals to B over sine B, equals to C over sine C. This formula is true in any triangle. We'll repeat again. A over sine A equals to B over sine B equals to C over sine C. So from this formula, we will derive that A over sine A equals to B over sine B. So I will copy triangle ABC, this triangle in a new page, and we will implement the law of sines in this triangle, triangle ABC. Okay. So this is triangle ABC that I copied from the original drawing. We know that side BC equals to B units, side AC equals to A units, angle ABC equals to 30 degrees, and angle ACB equals to 100 degrees. We'll find out the value of the missing angle, angle BAC. We'll define this angle as angle X. According to the rule that the sum of the angles in any triangle is equal to 180 degrees. So in triangle ABC, the sum of the angles must be equal to 180 degrees. That is to say, angle X plus 100 degrees plus 30 degrees must be equal to 180 degrees. Here we subtract 130 degrees from this equation, and we will get that angle X equals to 180 degrees minus 130 degrees is equal to 50 degrees. So we found out that the value of angle X is 50 degrees. We will substitute angle X by 50 degrees. Now we will implement the law of sines in this triangle, triangle ABC. According to the law of sines, we will get that A over sine 30 degrees equals to B over sine 50 degrees. So here we will divide the equation number 1 by B, and then we will multiply it by sinus 30 degrees, and we will get, according to equation number 1, A over B equals to sinus 30 degrees or sinus 50 degrees. Okay. In the next step, I will copy triangle ADC in a new page, and we will implement the law of sines in this triangle, triangle ADC. But first of all, we just right now found out that angle BAC, this angle equals to 50 degrees. So if we define angle DAB, if we define this angle as angle theta, then 50 degrees minus theta will be the value of this angle that is actually 50 degrees minus theta. That is to say, the value of angle DAC will be equal to 50 degrees minus theta, because it is the whole angle BAC equals to 50 degrees, and if we subtract from 50 degrees the value of this angle that is angle theta, we will get this angle that is actually angle DAC will be equal to 50 degrees minus theta. Okay. So if we focus on triangle DAC, we know that the sum of the angles must be equal to 180 degrees. So 50 degrees minus theta plus 100 degrees plus the size of this angle, angle ADC, that the angle that we are looking for, that we will define as angle Y. In total, the sum of those three angles must be equal to 180 degrees. So here we subtract 150 degrees from this equation, and we will get that minus theta plus Y equals to 180 degrees minus 150 degrees is 30 degrees. We will add theta to this equation, and we will get that angle Y equals to 30 degrees plus theta So here angle Y, the angle that we are looking for, equals to 30 degrees plus theta. Now I'll copy triangle ADC in a new page, and we will implement the lobe signs in this triangle, triangle ADC. So I copied triangle ADC in this page from the original drawing. Angle ACD equals to 100 degrees. Angle ADC, the angle that we are looking for, equals to 30 degrees plus theta, and angle DAC equals to 50 degrees minus theta. According to the law of sines, we will get that A over sine of 30 degrees plus theta equals to B over sine of 100 degrees So here we will divide the equation number 2 by b, and then we will multiply it by sinus 30 degrees plus theta, and we will get that according to equation number 2, a over b equals to sinus 30 degrees plus theta over sinus 100 degrees but we have already found out that according to equation number 1, a over b equals to sinus 30 degrees over sinus 50 degrees. So we have two expressions for a over b. Therefore, we will create equation number 3 that states that a over b according to equation number 1 must be equal to a over b according to equation number 2. So according to equation number 3, a over b according to equation number 1 is that is sinus 30 degrees over sinus 50 degrees. Must be equal to a over b according to equation number 2, that is actually sinus 30 degrees plus theta over sinus 100 degrees. I'll repeat again. Equation number 3 states that a over b according to equation number 1 equals to a over b according to equation number 2. So here we'll cross multiply equation number 3, and we will get that here sinus 30 degrees is 1 over 2 times sinus 100 degrees equals to sinus 30 degrees plus theta times sinus 50 degrees we will use the trigonometric identity that sinus 2a equals to 2 sinus a cosine a we'll use this trigonometric identity for sinus 100 degrees, and according to this trigonometric identity we will get that sinus 100 degrees equals to 2 sinus 50 degrees cosinus 50 degrees, and it equals to sinus 30 degrees plus theta times sinus 50 degrees. Here 2 over 2 is 1, so 2 will get cancelled. We have sinus 50 degrees on both sides of equation number 3, so sinus 50 degrees will get cancelled. And what is left after we cancel sinus 50 degrees. What is left? It is actually cosine 50 degrees equals to sine 30 degrees plus theta. Here we will use the trigonometric identity that cosine alpha equals to sine 90 degrees minus alpha, and according to this trigonometric identity we will get that cosine 50 degrees equals to sine 90 degrees minus 50 degrees. That is to say, cosine 50 degrees equals to sine 90 degrees minus 50 degrees is 40 degrees. So we found out that cosine 50 degrees equals to sine 40 degrees. Therefore, we can substitute cosine 50 degrees in this equation, equation number 3, by sine 40 degrees. We will do it now, and we will get that sine 40 degrees equals to sine 30 degrees plus theta. Sine 40 degrees equals to sine 30 degrees plus theta means that 40 degrees equals to 30 degrees plus theta. Here we'll subtract 30 degrees from this equation, equation number 3, and we will get that angle theta equals to 40 degrees minus 30 degrees is 10 degrees. So we found out that angle theta equals to 10 degrees, but the angle that we are looking for, that is angle ADC, equals to 30 degrees plus theta. So 30 degrees plus theta will be equal to 30 degrees plus 10 degrees, because theta equals to 10 degrees. So it is 40 degrees. So the angle that we are looking for, that is actually angle ADC, equals to 40 degrees. So we found out that angle ADC, that is actually equals to 30 degrees plus theta equals to 40 degrees. Okay, so the answer to the question is that the angle ADC equals to 40 degrees. We finished with the first method. In the next step, I will present to you how to find out the value of this angle, angle ADC, according to the second method. In the second method, we will define side BC of triangle ABC as A. That is to say, the length of side BC is equal to A units. And according to what is given us in the question, AD equals to BC. And according to our definition, BC equals to A. So from this equation, AD equals to BC equals to A, we will derive that AD also equals to A. So we can write here that AD equals to A. In the next step, we will extend side BC by a straight line. And then from point A we will go perpendicular to the extended BC. So this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. We will define the intersection point between the extended BC and between the perpendicular from point A as point E. I repeat again, the intersection point between the perpendicular from point A and the extended BC is defined as point E. Then we'll find out the value of angle ACE, the value of this angle, so we will define angle ACE as Y. We know that BC is one side of triangle ABC. BC is one side of triangle ABC, therefore it is absolutely a straight line. And when we extended the straight line BC by a straight line, we got line segment BE that it must be also a straight line. So we can write down that line segment BE is a straight line. And so BE, line segment BE is a straight line, and we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if you focus on the upper side of the straight line BE at point C, the sum of the angles must be equal to 180 degrees. Which angles we have in the upper side of BE at point C? We have 100 degrees plus angle Y. The sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. Here we will subtract 100 degrees from this equation and we will get that angle Y equals to 180 degrees minus 100 degrees is actually 80 degrees. So we found out that angle Y equals to 80 degrees. So we'll substitute angle Y by 80 degrees. In the next step, we will define side AE as Y, that is to say the length of AE is equal to Y units, and we will define side CE, this side CE as X, that is to say the length of side CE is equal to X units. And we will focus on the right triangle, triangle ACE. On the right triangle, triangle ACE, tangents 80 degrees. Equals to AE over CE. I will repeat again. In the right triangle, triangle ACE, tangents 80 degrees equals to AE over CE. But according to our definition, AE equals to Y and CE equals to X. Therefore, according to equation number 1, we will get that tangents 80 degrees equals to Y over X. I repeat again, according to equation number 1, tangents 80 degrees equals to Y over X. To Y over X. Here we will multiply equation number 1 by X. And we will get that according to equation number 1, Y equals to X times tangents 80 degrees. I repeat again, according to equation number 1, Y equals to X times tangents 80 degrees. In the next step, we will focus on the right triangle, triangle ADE. We will define the angle that we are looking for. Angle ADE is angle theta. So in the right triangle, triangle ADE, sinus theta equals to AE over AD. I repeat again, in the right triangle, triangle ADE, sinus theta equals to AE over AD. But AE equals to Y according to our definition. And AD equals to A according to what we have already found out. So sinus theta, in conclusion, sinus theta according to equation number 2 will be equal to Y over A. I repeat again, sinus theta according to equation number 2 will be equal to Y over A. Here we will multiply equation number 2 by A, and then we will divide it by sinus theta, and we will get that according to equation number 2, A equals to Y over sinus theta. But according to equation number 1, Y equals to X tangents 80 degrees, so we will substitute Y by X tangents 80 degrees, and we will get that according to equation number 2, A equals to Y, that is X tangents 80 degrees, according to equation number 1, over sinus theta. So according to equation number 2, A equals to X tangents 80 degrees over sinus theta, and Y equals to X tangents 80 degrees according to equation number 1. In the next step, we will focus on the right triangle, triangle ABE. On the right triangle, triangle ABE, tangent 30 degrees equals to AE over BE. I repeat again, on the right triangle ABE, tangent 30 degrees equals to AE over BE. But AE equals to Y according to our definition. And the value of BE, you can see from the drawing that BE equals to A plus X. In conclusion, according to equation 3, we will get that tangent 30 degrees equals to Y over A plus X. I repeat again, according to equation number 3, tangent 30 degrees equals to Y over A plus X. Here we will substitute Y by X tangent 80 degrees because Y equals to X tangent 80 degrees according to equation number 1. And we will substitute A by X tangent 80 degrees over sinus theta because A equals to X sinus 80 degrees over sinus theta according to equation number 2. So we'll do it now and we will get that according to equation number 3, tangent 30 degrees equals to Y according to equation number 1 is X times tangent 80 degrees, X times tangent 80 degrees, over A plus X. A according to equation number 2 is X tangent 80 degrees over sinus theta and we have also to add X. Actually, we will add X sinus theta, we will multiply X by sinus theta and then we will divide it by sinus theta, so we change nothing. So here we will move sinus theta from the denominator to the numerator and we will get that according to equation number 3, tangent 30 degrees equals to X times tangent 80 degrees times sinus theta over X times tangent 80 degrees plus X sinus theta So here we have x in the numerator and we have x also in the denominator, so x will get cancelled. And we also know that tangent 30 degrees equals to 1 over square root of 3 units, so we will substitute tangent 30 degrees by 1 over square root of 3 units, and we will get that according to equation number 3, tangent 30 degrees, it is actually 1 over square root of 3 units, equals to tangent 80 degrees times sinus theta over tangent 80 degrees plus sinus theta. So here we will cross multiply equation number 3 and we will get that tangents 80 degrees plus sinus theta equals to square root of 3 times tangents 80 degrees times sinus theta. Okay, so here we will subtract sinus theta from this equation, equation number 3. We will get that tangents 80 degrees equals to square root of 3 times tangents 80 degrees times sinus theta minus sinus theta. So here we will take sinus theta as a current factor. We will take out sinus theta as a current factor from this side of equation number 3, and we will get that tangents 80 degrees equals to sinus theta is taken as a current factor, and inside the brackets from this expression what is left after we took from it sinus theta, what is left, it is actually square root of 3 times tangents 80 degrees, and what is left from minus sinus theta after we took from it sinus theta as a common factor, what is left from it is minus 1. So here we divide this equation, equation number 3, by square root of 3 times tangents 80 degrees minus 1, and we will get that according to equation number 3, sinus theta equals to tangents 80 degrees over square root of 3 times tangents 80 degrees minus 1. Here we have tangents 80 degrees in the numerator and tangents 80 degrees in the denominator also. So we substitute tangents 80 degrees by sinus 80 degrees over cosine 80 degrees. And we will get that according to equation number 3, sinus theta equals to tangents 80 degrees is sinus 80 degrees over cosine 80 degrees divided by square root of 3 times tangents 80 degrees, and tangents 80 degrees is sinus 80 degrees over cosine 80 degrees minus 1. We'll substitute minus 1 by minus cosine 80 degrees over cosine 80 degrees. That is actually minus 1. So here we have cosine 80 theta, we have cosine 80 degrees in the numerator, and we have cosine 80 degrees in the denominator, so cosine 80 degrees will get cancelled. And what is left from equation number 3 after we cancelled cosine 80 degrees? What is left, it is actually, in this side of the equation, we left with sinus theta. That equals to sinus 80 degrees over square root of 3 times sinus 80 degrees minus cosine 80 degrees. Here we will multiply the denominator by 2 and then we will divide it by 2. So we get that sinus theta equals to sinus 80 degrees over, I'll repeat again, we will multiply the denominator by 2, so it is 2 times square root of 3 sinus 80 degrees then we will divide it by 2, so it will be square root of 3 over 2 minus cosine 80 degrees divided by 2. I'll repeat again, we multiplied the denominator by 2, here we have 2, and then we divide it by 2. Here square root of 3 is divided by 2, and here cosine 80 degrees divided by 2. So we change actually nothing, therefore it is allowable. It is allowable to multiply anything by 2 and then to divide it by 2. Okay, in the next step we will change square root of 3 over 2 by cosine 30 degrees because of the fact that cosine 30 degrees equals to square root of 3 over 2 here, and we will change here 1 over 2 by sine 30 degrees because of the fact that sine 30 degrees is equal to 1 over 2. And we will get that sine theta equals to sine 80 degrees over 2 times sine 80 degrees and we substitute square root of 3 over 2 by cosine 30 degrees. Here we substitute 1 over 2 by sine 30 degrees times cosine 80 degrees. Actually, the expression in the denominator, sine 80 degrees times cosine 30 degrees minus sine 30 degrees cosine 80 degrees, is very similar to the trigonometric identity that sine 80 degrees that sine A cosine B minus sine B cosine A equals to sine A minus B. Okay, sine 80 degrees cosine 80 degrees minus sine 30 degrees cosine 80 degrees is very similar to the trigonometric identity that sine A cosine B minus sine B cosine A equals to sine A minus B. Therefore, we actually can substitute our expression by sine A minus B according to this trigonometric identity. So we'll do it now, and we will get that according to equation number 3, sinus theta equals to sinus 80 degrees over, I will repeat again, we will substitute our expression by sine A minus B. In our specific expressions, A equals to 80 degrees and B equals to 30 degrees, so it will be sine 80 degrees minus 30 degrees. So in conclusion, we found out that according to equation number 3, sine theta equals to sine 80 degrees over 2 times sine 80 degrees minus 30 degrees. 80 degrees minus 30 degrees is 50 degrees. So I will write it down. According to equation number 3, we got that sinus theta equals to sinus 80 degrees over 2 times sinus 50 degrees. Here we will use the trigonometric identity that states that sinus 2A equals to 2 sinus A cosine A according to this trigonometric identity. We will get that the value of sinus 80 degrees equals to 2 sinus 40 degrees cosinus 40 degrees Okay, so in conclusion we found out that according to equation number 3, sinus theta equals to 2 sine 40 degrees cosine 40 degrees over 2 sine 50 degrees. We will use the trigonometric identity that states that sinus alpha equals to cosine 90 degrees minus alpha and according to this trigonometric identity we will get that sinus 50 degrees equals to cosine 90 degrees minus alpha, and alpha is 50 degrees, so sinus 50 degrees equals to cosine 90 degrees minus 50 degrees. That is to say, sine 50 degrees equals to cosine 90 degrees minus 50 degrees is 40 degrees. In conclusion, we found out that sine 50 degrees equals to cosine 40 degrees. Therefore, we can substitute sine 50 degrees in the denominator of this equation, equation number 3, by cosine 40 degrees. So we will do it now, and we will get that according to equation number 3, sinus theta equals to 2 sinus 40 degrees cosinus 40 degrees over 2 sinus over 2, and we will substitute sinus 50 degrees by cosine 40 degrees, because they are equal according to this equation. 2 times cosine 40 degrees. Here 2 over 2 is 1, so 2 will get cancelled. We have cosine 40 degrees in the numerator and cosine 40 degrees in the denominator, so cosine 40 degrees will also get cancelled. And we left only with the expression according to equation number 3. Sinus theta equals to sinus 40 degrees I repeat again, according to equation number 3, we found out that sinus theta equals to sinus 40 degrees. That is to say, theta equals to 40 degrees. Theta equals to 40 degrees. So here, the angle that we are looking for, that is actually angle ADC that equals to theta, equals to 40 degrees. Angle ADC that equals to angle theta equals to 40 degrees. So in both methods, we found out that the angle that we are looking for, angle ADC, equals to 40 degrees. In the next step, I will summarize the lecture. Actually, we found out the value of angle theta, this angle, in two different ways. In the first method, we defined side AC as A and side BC as B. And according to what is given us in the question, we know that AD equals to BC from one side, but from the other side, according to our definition, BC equals to B. So from this equation, AD equals to BC equals to B, we will derive that AD also equals to B. So we can write down here that AD equals to B. Okay. In the next step, I presented to you a new law that is actually the law of sines. According to the law of sines, in any triangle, if we have this triangle ABC, that could be any triangle, we know that side AB equals to C units, side AC of triangle ABC equals to B units, and side BC equals to A units. This is angle A, this is angle B, and this is angle C. Then according to the law of sines, we will get that A over sine A equals to B over sine B equals to C over sine C. And this equation is true in any triangle. So from this formula, we will derive that A over sine A equals to B over sine B. So I actually copied triangle ABC, this triangle, in a new page, and then we implemented the law of sines in this triangle ABC. So this is triangle ABC. We know that AC equals to A units, BC equals to B units, angle ACB equals to 100 degrees, and angle ABC equals to 30 degrees. It is given us in the question. The missing angle is this angle that we defined as angle X. And according to the rule that the sum of the angles in any triangle is equal to 180 degrees, we will get that angle x plus 100 degrees plus 30 degrees must be equal to 180 degrees in triangle ABC. Here we subtracted 130 degrees from this equation and found out that angle x equals to 180 degrees minus 130 degrees, that is to say angle x equals to 50 degrees. Then we implemented the law of sines in this triangle ABC according to the law of sines. A over sinus 30 degrees equals to B over sinus 50 degrees. Okay? Here we divided the equation number 1 by B and then we multiplied it by sinus 30 degrees. And so we got to equation number 1 that says that A over B equals to sinus 30 degrees over sinus 50 degrees. Then I copied triangle ADC in a new page and we implemented the law of sines in this triangle ADC. But before that, we just right now found out that angle BAC equals to 50 degrees. This angle equals to 50 degrees. So if we define angle BAD as theta, then 50 degrees minus theta will be equal to this angle that is actually angle DAC. Therefore, angle DAC equals to 50 degrees minus theta. Angle ACB equals to 100 degrees, it is given us in the question. And if we define the angle that we are looking for as angle Y, we will get that the sum of the angles in triangle ADC must be equal to 180 degrees. That is to say, this angle that is actually 50 degrees minus theta, plus this angle that we defined as angle Y, plus this angle that is equal to 100 degrees. The sum, in total, the sum of those two angles must be equal to 180 degrees. Here we subtracted 150 degrees from this equation, and we found out that minus theta plus y equals to 180 degrees minus 150 degrees is 30 degrees. Here we added theta to this equation and found out that angle y equals to 30 degrees plus theta. This angle equals to 50 degrees minus theta, and this angle ACB equals to 100 degrees, according to what is given us in the question. In the next step, I copied triangle ADC in a new page, and we implemented the law of sines in this triangle ADC. So this is triangle ADC that I copied from the original drawing. We know that angle DAC equals to 50 degrees minus theta. Angle ACD is 100 degrees, it is given us in the question. And we just right now found out that angle ADC equals to 30 degrees plus theta. So according to the law of sines, if we implement the law of sines in this triangle ADC, we will get that A over sinus 30 degrees plus theta equals to B over sinus 100 degrees. A over sinus 30 degrees plus theta equals to B over sinus 100 degrees. Here we divided the equation number 2 by B and then we multiplied it by sinus 30 degrees plus theta. And we got that according to equation number 2, A over B equals to sinus 30 degrees plus theta over sinus 100 degrees. This is according to equation number 2. But we have already found out that according to equation number 1, A over B equals to sinus 30 degrees over sinus 50 degrees. So we have two expressions for A over B. Therefore, we created equation number 3 that states that A over B according to equation number 1 must be equal to A over B according to equation number 2. Okay? So here we have A over B according to equation number 1 is sinus 30 degrees over sinus 50 degrees, and it must be equal to A over B according to equation number 2 that is actually sinus 30 degrees plus theta over sinus 100 degrees. Here we know that sinus theta is 1 over 2. We cross-multiplied this equation number 3, and we found out that 1 over 2 times sinus 100 degrees equals to sinus 30 degrees plus theta times sinus 50 degrees. Here we use the trigonometric identity that sinus 2a equals to 2 sinus a cosine a in order to simplify sinus 100 degrees. According to this trigonometric identity, we will get that the value of sinus 100 degrees equals to 2 sinus 50 degrees cosine 50 degrees, and it equals to sinus 30 degrees times sinus 50 degrees. Here we have 2 over 2 is 1, so 2 will get cancelled, and we have sinus 50 degrees on both sides of equation number 3, so sinus 50 degrees will also get cancelled. And what is left after we cancel sinus 50 degrees from equation number 3, what is left? It is actually here, in this side we have cosine 50 degrees, and in the other side we have sinus 30 degrees plus theta, so cosine, according to equation number 3, cosine 50 degrees equals to sinus 30 degrees plus theta. Then we use the trigonometric identity that states that cosine alpha equals to sinus 90 degrees minus alpha. According to this trigonometric identity, we will get that cosine 50 degrees must be equal to sinus 90 degrees minus 50 degrees. 90 degrees minus 50 degrees is 40 degrees, therefore we actually found out that cosine 50 degrees equals to sine 40 degrees. What does it mean? It means that we can change cosine 50 degrees in this equation number 3 by sine 40 degrees. Why? Because they are equal to each other. We did it, and we got that sine 40 degrees equals to sine 30 degrees plus theta. What does it mean that sine 40 degrees equals to sine 30 degrees plus theta? It means that 40 degrees equals to 30 degrees plus theta. Here we subtracted 30 degrees from this equation number 3, and we found out that angle theta equals to 40 degrees minus 30 degrees is 10 degrees. So we found out that angle theta equals to 10 degrees, and the angle that we are looking for, that is actually angle ADC, equals to 30 degrees plus theta. If theta equals to 10 degrees and angle ADC equals to 30 degrees plus theta, it means that angle ADC equals to 30 degrees plus 10 degrees, that is to say angle ADC equals to 40 degrees. So we found out that angle ADC that equals to 30 degrees plus theta equals to 40 degrees. This is according to the first method. Then I presented to you how to find out the value of angle theta according to the second method. In the second method, we defined side BC of triangle ABC as A. We know, according to what is given us in the question, AD equals to BC. But according to our definition, BC equals to A. From this equation, AD equals to BC equals to A, we will derive that AD also equals to A. So we can write here that AD also equals to A. In the next step, we extended side BC of triangle ABC, and then from point A, we drew perpendicular to the extended BC. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. And we defined the intersection point between the extended BC and the perpendicular from point A as point E. Then we found the value of this angle, angle ACE. First of all, BC is one side of triangle ABC, therefore it is absolutely a straight line. And then, when we extended the straight line BC by a straight line, we got line segment BE that must be also a straight line. So we know that line segment BE is a straight line, and we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of the straight line BE at point C, according to the rule that I mentioned, the sum of the angles must be equal to 180 degrees. That is to say, 100 degrees plus this angle that we defined as angle y must be equal to 180 degrees. Okay, at the upper side of the straight line BE at point C, the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. That is to say, 100 degrees plus the size of angle y must be equal to 180 degrees. We subtracted 100 degrees from this equation and we found out that angle y equals to 180 degrees minus 100 degrees is 80 degrees. So we found out that angle y, this angle, equals to 80 degrees. Then we focus on the right triangle, triangle ACE. On the right triangle, triangle ACE, tangents 80 degrees equals to AE over CE. I repeat again. On the right triangle, triangle ACE, tangents 80 degrees equals to AE over CE. But AE equals to Y and C equals to X according to our definition. So in conclusion, we found out actually that tangents 80 degrees equals to Y over X. We multiplied this equation number 1 by X, and we found out that Y equals to X times tangents 80 degrees. According to equation number 1, Y equals to X times tangents 80 degrees. Then we focus on the right triangle, triangle ADE. We define the angle that we are looking for, that is actually angle ADE, is theta. So in the right triangle, triangle ADE, we know that sinus theta equals to AE over AD. I'll repeat again, in the right triangle, triangle ADE, sinus theta equals to AE over AD. But AE equals to Y according to our definition, and we have already found out that AD equals to A. So in conclusion, we found out that sinus theta according to equation number 2 equals to Y over A. Here we multiplied equation number 2 by A, and then we divide it by sinus theta, and we got that A equals to Y over sinus theta. According to equation number 2, A equals to Y over sinus theta, but according to equation number 1, Y equals to X times tangents 80 degrees, so we can substitute Y by X times 80 degrees. We did it, and we got that A equals to X times 80 degrees over sinus theta. This is according to equation number 2, and according to equation number 1, Y equals to X times tangents 80 degrees. Then we focused on the right triangle, triangle ABE. On the right triangle, triangle ABE, we know that tangents 30 degrees equals to AE over BE. I'll repeat again, on the right triangle, triangle ABE, we know that tangents 80 degrees, tangents 30 degrees equals to AE over BE, but according to our definition, AE equals to Y, and BE equals to A plus X. So in conclusion, we found out that tangents 30 degrees equals to Y over A plus X. Here, according to equation number 1, Y equals to X times 80 degrees, so we substituted Y by X times tangents 80 degrees. And according to equation number 2, A equals to X tangents 80 degrees over sinus theta, so we substituted A in this equation number 3, by X tangents 80 degrees over sinus theta, and we also have to add X to this equation. So actually we added, we multiplied X by sinus theta, and then we divided by sinus theta, so we changed nothing. So we got this equation, and then here we moved sinus theta from the denominator to the numerator, and we got that tangents 30 degrees equals to X tangents 80 degrees times sinus theta over X times tangents 80 degrees over plus X sinus theta. We have X in the numerator and we have X in the denominator, so X will get cancelled. And we also know that tangents 30 degrees equals to 1 over square root of 3 units. So we substituted tangents 30 degrees by 1 over square root of 3 units. And so here tangents 30 degrees equals to 1 over square root of 3 units. And in the other side of equation number 1, we have tangents 80 degrees times sinus theta over tangent 80 degrees plus sinus theta. Here we cross multiply this equation, equation number 3. And we got that tangent 80 degrees plus sinus theta equals to square root of 3 times tangent 80 degrees times sinus theta. Here we subtracted sinus theta from this equation, equation number 3, and we found out that tangent 80 degrees equals to square root of 3 times tangent 80 degrees times sinus theta minus sinus theta. Here we took sinus theta as a common factor on this side of equation number 3, and we got that tangent 80 degrees equals to sinus theta, so sinus theta was taken as a common factor. So inside the brackets, what is left from this expression is square root of 3 times tangent theta, and what is left from minus sinus theta after we took from it sinus theta as a common factor, what is left from it is actually minus 1. Then we divided this equation, equation number 3, by square root of 3 times tangent 80 degrees minus 1, and we got that sinus theta equals to tangent 80 degrees over square root of 3 times tangent 80 degrees minus 1. Here we substituted tangent theta by we substituted tangent 80 degrees by sinus 80 degrees over cosine 80 degrees. So here sinus theta equals to tangent 80 degrees sinus 80 degrees over cosine 80 degrees over square root of 3 tangent 80 degrees. It is actually square root of 3 times sinus 80 degrees over cosine 80 degrees, and we substituted minus 1 by minus cosine 80 degrees over cosine 80 degrees. Here we have cosine 80 degrees in the numerator and we have cosine 80 degrees in the denominator, so cosine 80 degrees will get cancelled. And what is left from equation number 3 after we cancelled cosine 80 degrees? What is left is sinus theta equals to sinus 80 degrees over square root of 3 times sinus 80 degrees minus cosine 80 degrees. Here we multiplied the denominator by 2 and then we divided by 2, and we got that sinus theta equals to sinus 80 degrees, so we multiplied the denominator by 2 and then we divided by 2 here and here also, so we got that square root of 3 over 2 times sine 80 degrees minus cosine 80 degrees over 2. Okay, and then we substituted square root of 3 over 2 by cosine 30 degrees, so in conclusion we got here sinus theta equals to sinus 80 degrees over 2 times sinus 80 degrees, and we substituted square root of 2 by cosine 30 degrees. Here we have minus cosine 80 degrees over 2, so we substituted 1 over 2 by sine 30 degrees, so in conclusion we got here sine 30 degrees, that is actually 1 over 2 times cosine 80 degrees. Actually, the expression in the brackets, sinus 80 degrees, cosine 30 degrees, minus 30 degrees times cosine 80 degrees, is very, very similar to the trigonometric identity that sine A cosine B minus sine B cosine A equals to sine A minus B. So, according to this trigonometric identity, we can substitute our expression by sine A minus B. So we did it. And A in our specific expression is 80 degrees and B is 30 degrees. So sine A minus B, it is actually sine 80 degrees minus 30 degrees. So in conclusion, we found out that according to equation number 3, sine theta equals to sine 80 degrees over 2 times sine 80 degrees minus 30 degrees. 80 degrees minus 30 degrees is 50 degrees. So in conclusion, we found out that sine theta equals to sine 80 degrees over 2 times sine 50 degrees. We use the trigonometric identity that states that sine 2 theta equals to 2 sine theta cosine theta. And according to this trigonometric identity, sine 80 degrees will be equal to 2 sine 40 degrees times cosine 40 degrees. And we have to divide it by sine 50 degrees. According to the trigonometric identity that sine alpha equals to cosine 90 degrees minus alpha, we will get that the value of sine 50 degrees equals to cosine 90 degrees minus 50 degrees. 90 degrees minus 50 degrees is 40 degrees. So we actually found out that sine 50 degrees equals to cosine 40 degrees. Okay, so according to this equation, we can substitute sine 50 degrees in the denominator here by cosine 40 degrees because they are equal to each other. We did it and we got that sine theta equals to 2 sine 40 degrees cosine 40 degrees over cosine 40 degrees. 2 over 2 is 1, so 2 will get cancelled. Cosine 40 degrees over cosine 40 degrees is 1, so cosine 40 degrees will also get cancelled, and we left only with sine theta that equals to sine 40 degrees according to equation number 3. That is to say theta equals to 40 degrees. So we found out that according to the equation number 3, the angle that we are looking for, that is angle ADC that equals to theta, equals to 40 degrees. So this angle equals to 40 degrees. So angle ADC equals to 40 degrees in both methods. Okay, we found out that the angle that we are looking for, angle ADC, equals to 40 degrees in both methods. Okay, that's all. Thank you very much.